Morning, everybody. Welcome to day 26 of Math 133. We're getting toward the end, so uh, day 30 will be our last day. Um, Today we're going to be covering the cumulative review number 7, and that's on page 595 in your course pack. Um, there's cumulative review number 8. We're not going to get a chance to cover, so the cumulative review that we're doing today covers chapters 1 through 10. Cumulative review number 8 covers chapters 1 through 11, and the final exam covers chapters 1 through 11. So, cumulative review number 8 is a good one to work on to study for the final. Today, though, uh, we've started looking at chapter 11 for our lecture notes. So that's the last of the material is chapter 11. But anyway, so today we're going to be on page 595. If you click on the cumulative review number 7 in Canvas, it'll take you to this page, and there is a link that you can click on because there are a couple of data sets that we'll need. So when you click on that, it'll bring you to this giant document that has all the different data sets for all the different worksheets. You have to scroll almost to the bottom to find cumulative review number 7. So that's right here. So you'll click on the Google Sheet, and that'll open up uh, the um, the sheets with all the numbers for question number 1. When you click on this one for StatCrunch, this one wasn't working for me earlier. Yeah, it's still not working for me. So, okay, so we'll address that when we get to it. But at the very least, we've got the Google Sheet. Um, okay, so page 595. So here's all of the data that matches up with the data from the Google Sheet. And we've done a couple of these before. It's been a while, but so uh, when we're doing the mean and the standard deviation, you can go to page 254. And there were 3 methods on page 254 on how to calculate mean and standard deviation. In this case, we don't have the raw data because we don't have data in a single column. Okay. Um, we have what's called a frequency distribution, data in a table with whole numbers for frequencies. So this is method 2. Find the mean and the standard deviation. You need page 254, method 2. Okay. All right. Following table presents the numbers of screenings for breast cancer and cervical cancer by different race, ethnicities for sample patients in the US. So patient is randomly selected. Find the probability of selecting someone who uh, is screened for cervical cancer. So our total is right here. So probability equals the number of wanted things, which we sometimes write as X, over the total, which we sometimes write as N, X over N. Okay. So in this case, uh, we're checking if the person was screened for cervical cancer. So that's this number here, 10,487 divided by our total, which is 17,176. Okay. So you put that into your calculator and that'll give you your number. Okay. Um, when you see the word or in statistics, okay, you'll use either just add them together, okay? That's if they're disjoint. So here, for example, someone can't be Asian and Hispanic at the same time, so these are disjoint. So you just add the two probabilities together, okay? On the other hand, if you have an or and they're not disjoint, that means that there's an overlap. That means that this, you'll have to subtract off where the two happen at the same time. So that would happen here for part D. You want to subtract off the overlap. So this is asking find the probability that someone is Hispanic or screened for cervical cancer. So you'll find the probability of Hispanic, probability of cervical cancer, and then subtract off Hispanic and cervical cancer. Okay. All right. Would any of the events A through E be considered unusual? So it's unusual if the probability is less than 5%. Okay. For each of the following, circle true or false as appropriate. If false, explain why. So sampling bias arrives from the fact that all samples are slightly different and no sample perfectly mirrors the population. True or false? Do you guys know the answer for this one? 3A, do you think true or false? Take a guess. True or false? False. Thank you, Andrew. So sampling bias was where you select your sample, but it's not random. And if it's not random, then you end up could be picking things that uh, are not representative of the population. So it sounds very similar to what this is saying, but what this is saying is when you do a sample, uh, you're never going to perfectly match the population because your sample is random, right? So, um, whenever we're calculating our mu or our p value, um, that's what we're trying to approximate, and our sample is going to get close to that. How close to that? That's, what we've measured with like confidence intervals and things like that. Um, but basically, there's always going to be sample error. So if this word had said sampling error, then we would have said true. Okay. So what this is describing here is sampling error. Okay. So yeah, let's put that right here. Sample error. For medical screening tests of a communicable disease such as COVID, in general, type 1 errors are the equivalent of a false negative test. True or false? What do you think, guys? True or false? Everyone's in a pre-turkey coma. Yeah, false. Type 1 is false positive. And then type 2, that's false negative. And I always get those confused. So I would just write this on your 8.5 by 11 piece of paper for the final, because I always forget which one's which. So, all right. A researcher carried out a hypothesis test using a two-tailed alternative hypothesis. Which of the following test statistics is associated with the smallest p-value? So in our normal curve here, right here is 0. Uh, if you have a z-value that's very close to 0, like, 0 0.1, you're going to shade almost half of your uh, normal curve. And actually, if it's a two-tailed test, you're going to shade a lot of your normal curve, okay? But if you want a very small p-value, then you want something like this, where your z-value is very far away from 0, right? So you want something like 3 or -3. Okay, so which of these are farthest away from 0? So it basically, ignoring the negative, which one is biggest? So this one, negative 3.12. 3.12 is going to be way out here, okay? And so you're going to be shading a very little bit on that side and a very little bit on that side. Researcher carried out a hypothesis testing into, so same thing, using a two-tailed hypothesis, which of the following is associated with the largest p-value? So in this case, so your p-value is the part that you're shading, so you want a number that's very close to 0. So the number that's the smallest, ignoring the negative, which would be this one, okay? So if this was 0.19, right here is negative 0.19, okay? You're going to shade a lot, almost 100% of your normal curve. Okay, it's going to be like 80 or 90. Okay. All right, page 3, page 597. Quality control manager believes that the average calories per 5-ounce serving of vanilla yogurt is less than 175 calories. They gather a random sample of vanilla yogurts. So this is the sample that they actually gave us. Um, and so uh, this is the number of calories in each serving of the yogurt. Okay. Um, so find the following, give 3 decimal places. So we need the mean, the standard deviation, and the number. So after we do that, verify the requirements to conduct a hypothesis test are met. So we want to make sure this is random, independent, and normal. Okay. And then use this 5% significance level, test the manager's claim. Okay, so the issue we have here is I need to find the mean and the standard deviation. They didn't give it to us. Okay. Um, so we're going to be doing uh page 560 or 263. Okay. hypothesis test for a single mean. So the formula that they have here requires us to know the X bar value, which is the mean of the sample and the standard deviation of the sample. Okay, so we're going to need to calculate that here. For standard deviation, uh, we have three methods on page 254. And in this case, we have just the raw data. And so this is method one. Okay. But my link for StatCrunch is not working. Oh, now it is. Oh, nope, but this is not the right one. This is cumulative review number 8. Well, that's working, so that's good news. So when you guys work on cumulative review number 8, you're good to go. The one for 7 is the one that's not working for me, but that's okay. So what we're gonna do is we're gonna come in here to StatCrunch. Uh, so you can just sign in, click on this orange button, and open a StatCrunch uh, blank sheet here. And so I'm just going to enter these calorie counts uh, manually. So there's not that many, right? 160, 200, 220, 230, 120, 80. So I've got 14. Let me make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. Okay, yeah. So I got all those. So once you have all those entered in, on page 254, we could use method one, which is summary stats, columns. And we'll select our calories. And we need the mean and the standard deviation. So I can just hit compute. I'll write in our numbers here. So mean is 157.857. Standard deviation. We want the regular standard deviation, not the unadjusted one, because this is a sample. And n equals 14. I already counted 14 just to make sure I counted the ones on the paper. So there's 14 numbers here. Okay. Because we're going to need those because when we do 263 and we put in our information into StatCrunch in order to calculate our p-value. So you're going to go stat t-stats one sample. If you do one sample with summary, it's going to ask you for the mean and the standard deviation, which we just calculated. Okay. Um, or uh, you could also do stat t-stats one sample with data because we actually have the data right here. And so you just tell it which column is your data, and then you don't have to enter any of that. You just tell it, okay, I need to do hypothesis test. Tell it what you want to, your null hypothesis is. Tell it whether you want a one-tail or two-tail test, and you hit compute. Okay. And when you do that, it'll actually calculate the standard deviation and the mean for you. Okay. All right. So uses a 5% significance level test to test the manager's claim. So there's 6 steps on page 263. The first, so we write out our null hypothesis. And it's always going to be mu equals or p equals, depending on whether you're looking at testing a mean or a proportion. In this case, we're testing whether uh, the average calories for 5 ounces of yogurt is less than 175. So your null hypothesis is always going to be equals 175. Okay. And this one will be less or greater or not equal. In this case, we're looking at less than. Okay. So if we were to back over here in StatCrunch, stat tstats one sample with data, and you do calories and you tell it, okay, I want to compare this to 175, less than, and if you hit compute, so notice that it actually gives you the sample mean already. So that's right here. Okay. We'll come back to this. Let's move on to the next page. In 2022, 25% of US adults said they would buy an electric vehicle for their next purchase. A researcher at Ford Motor Company believes the percentage of US adults who say they would buy an EV is now higher. Okay. They gather a random sample of a bunch of people, found that 29% would buy electric vehicles. Fill in the following table. Okay. So I want to point out the reason why we do these hypothesis tests. So in 2022, 25% of US adults said they would buy an electric vehicle, right? This researcher says, I think that now that, it's 2025, I bet that number's gone up. So they do their random sample and they get that 29% would buy an electric vehicle. Why is it that they don't stop right here and say, oh, 29% is higher than 25%? So that means that the uh, percentage has gone up. Why can't you just stop there and say, okay, yeah, I, I validated my claim. My claim was that it's gone up in the last 3 years. That percentage has increased. Why can't you just compare these two numbers? Why do you have to do all this hypothesis test stuff? And the reason why is because you took a random sample. Okay. You didn't test the entire population of all US adults. You tested 1,254 adults. Okay. So, since it's a random sample, there is some chance that you ended up just picking a bunch of people who are, very environmentally focused. And so there's a chance that this sample that you took is not necessarily biased, but because it's random, it could end up, being higher or lower than the true population proportion. Okay. So, let's say you had done this and your percentage came out to be 25.1. Well, back in 2022, it was 25%. And now it's at 25.1. Yeah, that's an increase. But if you did another sample, there's a chance that you would have gotten 24.9. Okay. So when you're doing a hypothesis test, what you're doing is verifying that it didn't matter that you did a random sample. Okay. Since I did a random sample, my percent, my sample proportion, my p hat, could have been higher or lower depending on who I sampled, who I picked in my sample. Okay. We saw that with the M&Ms that some people had, a high proportion of blue M&Ms, some people had a high proportion of yellow M&Ms. Um, but all of them fell in some kind of expected range. Okay. That's what our confidence interval shows is where that expected range is. Okay. So what the hypothesis testing is doing is it's saying, okay, yes, you're higher than you were, but are you high enough that you can make a claim with, 95% confidence that it didn't matter that it was random? You could sample any number of people, it doesn't matter who you sample, you're always going to get that this p-value, this proportion, this p hat is higher than it was back in 2022. Okay. That's ultimately what all this hypothesis testing is doing is, you can't just compare your sample and you can't just take your sample and say that sample is for sure representative of what the true population proportion is. So anyway, that all said, uh, we can right here. So X, so we know that P hat is equal to X over N. That means that X equals N times P hat. Okay. So you know what this is, you know what this is, you just multiply them together. Okay. What are the researchers' hypotheses? So the whole hypothesis is that P equals, uh, so what's our P value? So this one's P hat, because that's the proportion in the sample. So what are we comparing against? We're comparing against 25%. Because this researcher thinks that the alternative hypothesis is true. They think that it's gone up. So they think that now in 2025, the percent has gone up, it's higher. Okay. And the null hypothesis is saying, no, it's the same. By the way, it's probably not the same, right? But we don't actually know if it's gone up very much or if it's gone down. And that's why when you're testing the alternative hypothesis, you want the researcher is hoping that the alternative is true. And that's usually what happens in research is you're hoping that the alternative is true. Okay. But we need to actually show that it's gone up by enough that we can claim that there's a significant difference. The term is statistically significant. Is there a statistically significant difference between these two? Okay. All right. Anyway, we need to check, make sure our sample's good. So we got to check and make sure our sample's independent and random and normal, which normal just means it's a big enough sample, right? So, okay, I'm going to stop there with our hints and we're going to go back through our worksheet and fill in all the rest. Okay.